Good afternoon. Thank you for being here today. We are Ponce, Valentin, and Hildermann Axel. We are 20 years old. We are a student of electromechanical engineering at a National Technological University in Paraná City, Argentina. Axel is from Exequiel, 56 kilometers away from the university, while I live in Paraná City. As UTN student, we would like to address a problem that we experience every day at the premises of FRP. At this moment, there are some students who want to have access to hot water, to have a drink coffee or drink mate, but they cannot do it because the dispensers of FRP provide hot water inefficiently and ineffectively. The problem can be faced with conventional devices, but as future engineers, we want to solve the problem with eco-technology, in promoting the use of sustainable energy. For this reason, we consider that we can use solar water heating systems.
The purpose of the presentation is to show an ecological and efficient solution to address the lack of hot water at UTN FRP premises. In other words, in this presentation, we will carry out the analysis of the problem and show tools and resources that electromechanical engineer Carfat provides to develop the sustainable project. And this is the way we have organized this presentation. First, we are going to describe the context of the problem and describe the problem in detail. Then we are going to explain causes of the problem and consequences that problem generates at UTN FRP premises. Finally, we are going to give a sustainable solution and analyzing its positive and negative aspects. Now, Valentin is going to describe the context of the problem.
The UTN FRP is in Paraná City. This place is an urban city in continuous development, but only a little part of this development is sustainable. So, it is a good place to promote the sustainability. Paraná stands out in its zone because there are a lot of universities and career paths to study. One of these universities is UTN. The UTN is a national university that is famous for its engineering career paths. As we mentioned before, the place in question is UTN in Paraná City. In the picture, we can see that this university is in the center of Paraná City. This is on Almafuerte Avenue near Ayacucho Street. In this zone, there is much traffic and there are a lot of people circulating every day. Also, there are basic services like electricity, natural gas, and water. The picture shows that around UTN there are not all trees or buildings, so this place gets a lot of sunlight. This sunlight can be used with eco-technological devices. One example for this is the water tank heater. Another picture was taken from Mañesco School, which is in front of UTN. Yes, from this place, we can see that at UTN there is a big roof. This is big adventure for this project, since solar energy is crucial for it. This place is a good option to develop a sustainable engineering project that answers to the need of the university. Now, Axel is going to describe the problem.
Perfect. We usually attend many lessons, so we spend a lot of time at UTN FRP. Sometimes, if we want to have cold water, for example, to drink mate or coffee, we cannot do it because our university has an inefficient service of hot water. Also, there are 2 water dispensers. These dispensers are not known to provide hot water to the Entre faculty, where there are approximately 700 students daily. In other words, these dispensers provide hot water inefficiently and ineffectively.
Why, Axel?
Good. I will tell you now. The picture shows the energy consumption level of dispensers. This level is provided by its maker. In the middle, there is a letter and color scale. This scale represents the energy efficiency to device. This device is old because the green letter B highlights the fact that it is currently inefficient, positioning in a 5th current scale rating. At the bottom of the picture, there is a table. That the dispenser has a low performance because this device cannot provide the necessary liters to face the students' demand of hot water. Currently, there are 2 devices at the university premises. Each of them has a capacity of only 6 liters of hot water per hour. So we can see the picture that the energy consumption of the devices is high in comparison with their capacity. Now, Valentin is going to talk about the causes of the problem, and then I am going to talk about the consequences that problem generates at UTN FRP premises. Let's go, Valentin.
Thank you. There are 4 main factors that give rise to the problem of the lack of hot water at UTN FRP facilities. The first factor is related to the number of hot water dispensers. As we mentioned before, there are around 700 students who daily use these dispensers, but there are only 2 devices at FRP. The second factor is connected with the 6 of these dispensers. These dispensers are kept small because they are designed for home or office use, where there is a little demand of hot water. These dispensers have a 6 liter capacity. The water is heated at 19 degrees Celsius in an hour. This capacity is very limited for our university, causing that several times when students look for hot water, it is cold. The third factor deals with the government lack of investment. There is an inefficient and ineffective service because there is a lack of investment for maintenance or implementation of new devices. The last factor is due to people's lack of investment. Society is still not interested or aware of high energy consumption because of the use of Class B or Class C appliances. Okay, Axel, and what are the consequences?
Perfect. Thank you, Valentin. Let's go. This problem has two consequences. The main consequence of the situation is the lack of hot water for the 700 students at UTN FRP. This aspect causes that when someone wants to drink mate, coffee, or tea, he or she cannot do this. Another important consequence is a high consumption of electrical energy because the devices are inefficient. This aspect is unsustainable for the environment. And also, this energy inefficiency causes an increase in the electricity bills for the university. Causes an increase in the electricity bills of the university because the dispensers are always turned on.
Okay, Axel, and what is the solution?
In order to address the situation, we propose the use of a new mixed system that can solve the problem. This mixed system consists in the implementation of a solar water heating system that works in combination with a current system. The system is mixed because a big amount of water is heating using solar energy, while there is some amount of water that is heated in the current devices by means of electrical energy. The principle of operation of the new system is that this sustainable solar device raises the temperature to approximately 70 to 80 grades Celsius. If the water does not reach this temperature, the current electrical devices can help heat the water until it reaches 80 degrees Celsius.
Now, Axel is going to tell the strength and weakness of the solution.
Thank you, Valentin. The system has several positive aspects, but also has it has some negative aspects. In relation to the positive aspects, it's eco-friendly, it promotes the sustainable development, its installation is easy, and its life expectancy is around 15 years. About negative aspects, there are two of these. The system is expensive, and it works on electrical energy when the die is clouded. Good. In conclusion, the ineffectiveness and inefficiency of water heating at UTN FRP can be improved. This can be done by means of renewable energy.
As has been explained before, the use of a water heating system that relies on electrical, as well as solar energy, has more benefit for the university community than drawback.
Thanks for your attention.